Um, so thanks everybody for coming. So welcome to Cleveland Big Data. It's March 15th, 2021, and my name is Doug Meal, and I'm the MC, the Master of Ceremonies. So on our agenda tonight, we've got three great talks. We've got Steph Hippo on Google SRE / utilizing SRE patterns in smaller organizations. We've got a great talk on, from Dipti on an introduction to PrestoDB for data platform engineers. And for the folks that don't know, PrestoDB is also the framework that is behind AWS Athena. And then Dan Kim is going to do a talk on what coffee and rock climbing can teach us about MapReduce. Also, I wanted to point out, I had a couple of comments a couple of months back that the old Meetup picture was making people nervous because there were a lot of people all clustered together. So a couple of months ago, I fixed it. I made a little collage here. I went back to middle school art class. I printed out a couple of pictures, threw a couple of masks on top. So I hope folks are satisfied. Emblematic of the Meetup with a Steggy Pizza people meeting and also one from the Mega Meetup. So hope folks are satisfied. So quick few announcements. So again, the Meetup approval reminder. Again, I had a lot of drive-by spam last year, so please don't take offense on the Meetup requests. I like to ask people just to make sure they're real people, because sometimes the bots do come in just to validate that they are real people. So yeah, please do not take offense if I ask you a couple of questions just to validate that you're a real person. Next, a regular staple of the Meetup is some recruiting shout outs, and now is a chance for everybody to shout out for anybody that's looking for something. Now, if you're looking to hire a position, or even if you're maybe looking for a new position, feel free to put it in the chat and I'll read it. So the first one is from Progressive Insurance. Progressive Insurance is looking for data engineers to help with analytics migration to the cloud. We also have positions in DevOps, development, management, security, and analytics. Check out progressive.com/careers. Thank you, Chris. Are there any other shout outs? KeyBank is looking for a senior cloud engineer. And Mick, how would people get in touch with, contact? Mick, can you put your contact information in there? Contact Mick Miller if you're interested in a senior cloud engineer position. Mick_Miller@keybank.com. Ahana is also looking for cloud software engineers, ahana.io. And please email dipti@ahana.io. OCLC is looking for data platform manager. Contact Jeff Wallace. That's wallacje@oclc.org. NASA is also looking for a data engineer. That's posted by Dan Oldham. And Dan, how do they get in touch with you? If you could post your email there in the chat. Okay, nasajob.gov. Thank you. Tom Callahan. Elastic's also looking for anybody for strong Java engineers from the Elasticsearch team. You can email tom.callahan@elastic.co. And there's a link from OCLC I'm not going to read because it's too long, but I will mention OCLC also has platform operations manager. Databricks is also hiring. This is excellent, guys. Thank you. Jessica Shifley, jessica.shifley, SHIFLEY @databricks.com. So thank you very much for the all the activity here. And we'll use the popcorn factor here, going once, going twice. Sounds like the popcorn is popped. So again, thank you for everybody doing the shout outs. And then, yeah, the next Next meetup is May 10th. Got a lot of great talks lined up. And again, the blockchain challenge is still in effect. There is a candidate for, wait, someone's raising their hand. I got to figure out how to do this. Phil raised their hand. What is, what's your, Phil, can you put it in the chat? Phil, do you have a question? Oh, well, okay, I don't see a question from Phil. Steph and Dan, hopefully you see the little good luck thing there from Tom. Yeah, the blockchain challenge is still in effect. We do have a candidate. I think it may happen in May. So again, the blockchain challenge is if anyone can explain blockchain to me, you may win the blockchain challenge. There is no prize money. There is no, there is nothing else other than the satisfaction that you will get in your career of explaining blockchain to me and to the and other folks in the meetup. So, so again, we have a candidate. So looking forward to that. And as always, thanks for Chris Barrett helping me scout for talent and speakers. And again, also thanks to Linux Foundation. We literally could not do this meetup without you because we're using the Linux Foundation ODPI Zoom account. Again, thank you very much, as always, to the Linux Foundation and for the Cleveland Big Data members. So it's great that we can still keep this meetup going, even in the pandemic. And I look forward to when, at some point in the future, we can all meet again. So with that, let's go on with Steph Hippo. And again, I do have to mention one thing just to mildly embarrass Steph and also me, because I'm going to show my age. Steph, if I'm correct, you were at the first mega meetup back in 2014. Is that correct? The one we had at the Great Lakes Science Center?
That is correct. I was there. I think there's still a picture somewhere, but maybe we'll keep that one.
Yep. So I am both proud of that, and also it makes me feel extremely old. That now you've gone on to, now you're coming back to do a presentation. So with that, I'll leave it to you. I am gonna, the timer is still here. So whenever you're ready, just take it away.
Okay, great. I actually cannot see a Zoom window right now, so if folks can't see me, shout, but otherwise we'll go ahead and get started. Hi, I'm Steph. So Doug talked me back into working for Explorus twice, actually. I turned down his offer the first time when I was still in college, but I later figured out he had the right idea, and I went and worked for McMiller for a few years before I moved out to Seattle, where I've been working for Google ever since. So now I am an SRE out of the Seattle office, and I'm here to talk a little bit about adopting SRE when you're not global yet. So yes, I'm now a site reliability manager at Google. I manage teams in Seattle and Munich. I did catch the tech community bug when I was in Cleveland, and I help with some of the Seattle tech community now. Since everything is virtual, we can talk about that at the end, but you're always welcome to join the Seattle meetups I help with virtually. If you take nothing else away from today, please take a closer look at your SLOs. That's going to be a big central theme of this talk. There's a joke that all SRE talks are really just SLO talks, but there's a good reason for that. So we'll get to that in a minute. Most famously, back when the office was a thing, I'm known as Zorro's Human. So that's my dog. He used to come to the office with me a couple times a week, but now he's with me every day during work from home. So here's the big thing. From past meetups, I've talked to a lot of folks about wanting to adopt SRE, but maybe they haven't convinced management yet, or they think they're too small, they're not sure how to do it, and so they want to know how to make their case. When the SRE book came out that Google published, we got some feedback that smaller orgs needed more actionable paths to Google's practices. So the SRE Workbook was the next book, and that addressed a lot of that, and that's actually going to be our focus today. You know, that's the part that you can move to after you already have buy-in. And so if you think you're still too small to start with SRE, that's probably not true. So we're going to cover some ways today on convincing your leadership, different things that you can try out with your organization and how you can set yourself up for success, but it's not going to be an overnight thing. SREs argue with numbers, and that's, if you're arguing with SREs, I would recommend bringing numbers as well. And so if you're trying to get management buy-in, I do recommend starting getting some hard numbers down. So businesses are built on numbers, and so you really need to hammer out your costs. Sometimes you're going to need to make estimates. That's fine. That's also a natural part of engineering. You just need to be clear on where those assumptions are. And so what kind of costs can we be thinking about? So the biggest cost that I see ignored ends up being churn. And I'm not talking about natural team turnover. It's good for folks to change teams, mix different skills, and move around within the company when the time is right and it's right for their career. I'm talking about the kind where people are exiting your team because they're miserable and they can't take it anymore. So if they're ready to leave your team in a matter of months, you've got something going on and we need to take care of that. Too much churn is expensive. You've got to recruit, you have to retrain every time you're bringing on new people. And if you're losing folks, then you're also losing knowledge on the team. And that investment can be the best investment you ever make when you're investing in a new team that you're building up. You want strong knowledge sharing to start. But if you're constantly churning that out, that's an overhead you're going to be paying over and over and over again. And so when you're putting these down, go talk to people in recruiting and people in sales and hiring and figuring out where those numbers are coming from and just how much is that costing your business. The other big cost is prioritizations. And this is where I see maintenance creep. So this is the first stop we're going to make on SLOs. So has anyone ever been out of engineering work to do and just said, gee, like, I wish we had more work to choose from? Because I've never had that happen at anywhere I've worked yet. And so we need some way to talk about our maintenance costs and how we're going to factor that into the new features that we need to develop in order to stay competitive within the field. So if you're not keeping that maintenance cost down up front, that graph's going to be up and to the right and not the kind of up and to the right we want. And that's going to slow your team down over time. So I tell people, please assume that you will be wildly successful. What is going to keep you successful year on year? And that's keeping that maintenance cost down. So these are 3 places that I recommend you go start looking. Just grab some numbers on what your current engineering practices are costing your company. So there are also some product considerations here. So engineering leadership perspective, I said those are all great reasons, but product leadership should care a lot here too. Coming back to that feature delivery, sometimes it sounds counterintuitive, but keeping your engineering team nimble above all else is probably the most important thing that you can do for team health. And so if they are never getting time to improve their infrastructure, if your engineering teams are just going to be spending all of their time addressing on-call load and putting out fires, that's not a good experience for your customers. It's not a good experience for your engineers. No one's going to be happy. That customer trust that you burn each time, that's one of those estimates that's hard to put a number on. But it's much harder to earn that back than it is to burn it. It's very easy to burn that. So product wants to know, what is the minimum availability that our customers are expecting for our product? When does it most matter and when does it not? Or maybe when does it matter less? A lot of times we focus just on that incident revenue loss. So, at Google, it's easy to put a dollar value on, say, an outage in ads. That might be harder, on something that's more of an analysis tool. You don't really know at right that minute what your customers are using it for. So being able to find ways to link your major outages and incidents directly back to the business cost will be very helpful in discussing and talking about those 3 categories with engineering leadership. So your incident revenue loss, please pay close attention to. User trust, again, like I said, much easier to burn than it is to earn. And so, you might get away with a couple incidents where your users are frustrated, but they're not leaving yet. When do you want to find out about when they've crossed the breaking point? Because that's when people stop signing new contracts. It's when they stop renewing subscriptions, and that impacts the business's bottom line. And so we want to figure out how we can optimize these in our favor. So this is where SLOs come in. And so the SLO stands for Service Level Objective. And that is basically what keeps users from being unhappy. You don't need to keep them thrilled. We need to keep them on with the business, but that's the minimum that you can get away with. And that's what you need to engineer to. Developing SLOs can be an absolutely awesome way to get multiple disciplines aligned on what the goals for the business are. So these are just a few. This is not an exhaustive list, but this is who, if you're starting out, involved right off the bat. So leadership, they need to be able to enforce these SLOs. So like what happens when we start missing these SLOs and customers are upset? Sales needs to know what customers are expecting versus what engineering can provide. This also really helps if you have competitors out there and you want your sales team to be able to show, here's how we're performing against other products, and hopefully making it an easy decision for your customer. Engineering needs to know how far away they currently are from the goal and what they need to do to get to those SLOs. Sometimes folks are tempted to put their SLO where their business is currently performing because engineers like to see things green. I recommend putting it where your customers are expecting it and then working your way out of the red, but then that solves your prioritization discussion. You need to start there with engineering to start meeting those SLOs. User experience, if you have it, that can be a game changer here. These are folks that might be interviewing customers directly and have a wealth of resources. Your first SLO is going to be wrong. That's fine. You can iterate on it. I find that UX can get you much closer on the first try if they have that in-depth knowledge of what your customers are looking for and expecting. Okay, so this is from the SRE Workbook. It says our on-call engineer gets paged about 100 times in a typical 24-hour shift. A lot of pages get ignored. Well, the real problems are buried under the pile. Where should we start? I hear this from a lot of meetups that I go to as their biggest pain point. And this is where I mentioned earlier, you can start seeing some of that churn. No one wants to live like this week after week. We do sometimes get folks that enjoy the adrenaline rush of a properly mitigated incident. I'm one of them, but if it's constant, if you're constantly feeling like things are under fire and you're never going to get out from underneath it, that does take a toll on morale and the quality of work. So first thing is to get your pager healthy. You should not be receiving hundreds and hundreds of pages. Most of those are probably noise. So how do we get from a sick pager to a healthy pager? So the first thing is healthy on-call rotations. Again, this talks about especially if you're small. If your engineering team's only a handful, consider pulling in from other teams. SRE should not just be an island. Sometimes they're used to just be kind of ops style. Once engineering ships it, we toss it over the fence, and now ops takes care of it. If you're an SRE team, keep your developers in the on-call rotation. Pull in your engineering leadership. I'm a manager and I still take a pager every once in a while. It's totally fine, but it helps people understand exactly where the pain is on on-call rotations. Make sure that you're picking reasonable handoff schedules. So my team is on call from 9 a.m. to 9 p.m. and then we hand off to Munich that goes 6 to 6. But we try to revisit that roughly annually to see if the people on the team have had different needs that change. And we talk about shifting that time around. That's really going to depend on your team, but that's if you're handing off. If you're doing 24-hour rotations, you will still need to hand over to whoever the next person is, but you'll want to talk to your team. Maybe Friday afternoon, for example, is a really bad time for handoff if people are coming and going. But talk to your team, see what makes the most sense for them, and make sure you revisit that. The next thing is take a team temperature check. So my team does a weekly on-call survey. We ask how on-call went, and management keeps an eye on that. And if we see too many weeks in a row where people are getting frustrated, we know that we need to spend some extra attention there if the team's struggling to get those pager numbers back down. And one way we do that, this is my favorite, biggest thing. If you don't feel like you're ready for SRE, this is the best thing you can do. So this is, we run ops review. So my team has a half-hour meeting every week where we review our pages from the previous week. We try to weed out any bad alerts. So if we got paged and there was nothing we can do, or it's recovering on its own, or it was just, too sensitive an alert, we make sure we go address that. People take action items, we go improve the alerting. If you are one of those people that the book described, where you're getting hundreds and hundreds of pages and it's just noise, I recommend just ripping everything out and starting over. If you think about weeds in like a garden bed, you would probably rake out the whole area and get things healthy and then start slowly adding things back in. Same thing here. If people are just exhausted all the time and they're constantly on edge because they think another fire is happening, they're not going to be in the right mindset to build better alerts and get that forward as fast as they would have just pulling it out and starting over. So again, if these alerts, the rule of thumb, if these alerts aren't helping you maintain your SLOs, they're not doing their job, get rid of them. The other thing is to look out for tipping points. Sometimes my team does get alerts that are useful, and one of the things that software is best at is growing, right? And so look out for tipping points. If you start seeing a particular page that's always coming at a certain time of day, or when you're reaching a certain amount of traffic, your engineering team should be looking out for that and getting ready to do the work that they need to scale that. Like, again, assume that you're going to be wildly successful, that it's going to grow, and that you're going to need to continue to expand. The third thing we cover is what needs a postmortem. So we write mini retrospectives on, you know, what died this week, what was the customer impact, and what are we going to do better next time. These are blameless. Basically, it should never be an engineer's fault. If something went down, we should be designing the systems that makes it very hard to do that. No, that's not accounting for malice, but I have yet to work with anybody that intentionally took down production. So if anyone does take it down, they're probably feeling bad enough. We're just going to focus on what we can do as a team to prevent that next time and not put that person in that position where they're able to take down production. All right, this is my advice for all of the heroes out there. Please don't be heroes. Tell management when this is getting unsustainable. So if you are the kind of person that keeps swinging in at 3 in the morning to help solve a page and get things wrapped up, and you keep saying it's fine, please don't. Make sure that engineering leadership is aware of just how much of a burden on-call is. You know, if you can't convince your leadership to step into the on-call rotation themselves, I do recommend sending them the notes from your ops review meeting every week so that they understand just what is the risk for the business. First of all, if we're seeing things continually break, but also that they understand just what their engineering teams are going through, so that they can keep an eye on if things are getting bad, and hopefully they can thank people and show appreciation if things are going really well. One of the tough parts of SRE is if you're doing your job really well, things are silent. And sometimes in the quiet, we forget that there are people making things quiet. And so if you're an engineering leader yourself, please watch out for that. Make sure you're appreciating your team. So this is from the SRE Workbook. It says we have a high turnover rate for on-call rotations. How do you address the knowledge gap within the team? So same thing, this kind of goes back to onboarding earlier. These are sort of your building blocks for on-call. First is knowledge sharing. So my team does an on-call training. We have a ton of documentation when you first get to my team at Google. Your first 6 months, you're not expected to go on-call. But after your first 3 months, you're expected to start working towards it. So we have different training videos to watch. You can shadow and reverse shadow. We'll talk about that in a minute. We go through our communication expectations, especially being distributed across 2 countries on opposite sides of the world. We do explicitly state we are going to over communicate rather than under communicate. You can sort of get cultural clashes there that can make on-call more stressful, and so we try to spell it out. The biggest thing my on-team mentor did for me at Google was an Ask Me Anything session 2 or 3 times a week when I first joined. At first, I was too nervous to ask questions, and I was trying to get out of it. So he would just pick a topic every day for that session. If I didn't have questions, he would just teach me something until I got the psychological safety where I knew that I could come ask him things. It was super effective. I'm still really grateful for that years later. So that's one way to build psych safety. The other way is going to be that blamelessness and that postmortem. So it's not just about writing those postmortems blamelessly. You really need to be mindful on how you and leaders are talking. And if you do see a leader slip up and they're sounding a little blamey, call it out. Shut it down to say, hey, remember, we're focusing on the system here, and move on. But we never want to make an individual engineer feel bad. Those postmortems, also make sure you share them widely. Sometimes I see teams, they want to hide what they view as their mistakes, but really we want to share them out so that other teams can save themselves, from those same pain points. So my team had an outage back in last fall that was pretty bad. We wrote up everything that happened, how we fixed it, and it had to occur a couple times before we figured it out. But another team was able to read our postmortem, realize they had the same risk, and plug the hole before it hit them. So by sharing that postmortem, we saved a team that we didn't even know had the same problem from going through the same pain. On-call prep, like I mentioned, shadow and reverse shadow. No one's ever fully ready for on-call, and that's fine. At some point, you just have to do it. One of my on-team mentors first told me, eventually the pager won't make you flinch. And I didn't believe him at the time. But later, they turned out to be right. I just needed to get paged a bunch. And I actually had a shift where we had a bug. I got paged like 30 times in a row for the same thing. I was no longer afraid of the pager. But somebody told me to have that expectation that it was okay for this to stress me out at first. And that really helped. Reverse shadow is when you put a new on-caller in the driver's seat, but have, you know, a trained engineer sort of shoulder surfing, talking them through, asking what they're thinking, and just there to help out or step in if they really need to. That can really help build an on-caller's question asking up as they're preparing to go solo. Wheels of Misfortune are where you simulate events in team meetings. So every other week, my team runs a Wheel of Misfortune. We call them WOMs for short. And if we don't have a recent page where something happened, you're allowed to make one up. But this is where we want to be testing people's ability to communicate in an incident, get creative if different things are down and they need other ways to get a view into the system, things like that. All right, I'm running a little behind here. I'll try to speed up. Sorry about that. So I also want to make sure you're taking care of your on-callers. This is another thing that comes up. Google can do follow the sun. We're a large, widely distributed company. If you're small and you're still in one location, you probably can't do that. But instead, focus on why Google does follow the sun. And that is so that we can take care of our on-callers. And these are a couple of ways that we do that. So the first is time off. At Google, I can take my on-call time that I spend outside of business hours back as either a proportional rate of vacation or bonus pay. It's up to me. That is really nice when I have a really stressful shift. You know, maybe I just take the next Monday off. I spend some time in the garden or baking donuts or something like that. The on-call compensation can be nice. Some people find relaxation more through the cash. I know folks that use their cash to make sure that they just take care of meals while they're on call. So they'll just order out, get a meal delivery service, something like that. And so the money is more important to them, make sure that they you know, can take other stress off other parts of their life during on-call. But the last one is most important because it's free in the sense that you're already paying for it, and that's agency. So make sure that you're empowering your on-callers to improve things. Give them the mic and listen to them. Like I said, send those notes around, send the postmortems around, make sure people are listening to them. But you're already paying for engineers, not pager monkeys. So make sure that they know that they're going to be listened to when they're raising issues. I just heard the bell. I'm on last slide, yep. I promise. All right.
Yeah, just if you could wrap this one up, please.
Yep. So that's my best advice for getting started. These are the SRE books. They are free to read online. I've had some folks have success with running book clubs at their company. They're not breezy weekend reads, but a chapter or two at a time as a group can be a good starting point to have some shared language to build conversation. And then this is the Beyond Seattle SRE Meetup. So I'll drop those links in the chat, but you can follow us on Twitter at SRE Meetup or join us, like I said, virtually in the Beyond Seattle SRE Meetup. Awesome. Thanks, Doug.
That is awesome. Thank you so much, Steph. And everybody give Steph a virtual clap here. Clap, 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 clap. That was some great stuff. Thank you so much. Next up is Dipti with PrestoDB. And
all right.
Whenever you're ready.
Sounds good. Steph, I just stole your screen. Hope that was all right. Can you guys see my screen here?
Yep, it looks good.
Okay, perfect. Let's get going. So hi, everyone. Thank you for letting me present to you about PrestoDB. Excited to be here. I'll talk a little bit about what Presto is, where it fits in the grand scheme of things in the data ecosystem, the architecture underneath it. It is open source, and I'll talk a little bit about Presto Foundation, and and talk about running Presto on the cloud with Ahana. A little bit about me, Dipti Borkar. I am the co-founder and chief product officer at Ahana. I also work very closely with the Linux Foundation. Presto is an open source project that Facebook donated to the Linux Foundation, and Presto Foundation was created with Facebook, Uber, Twitter. Ahana is a early member of the foundation as well as Intel, Upsolver, and others. And so it's in some ways it's a sister foundation to CNCF, where Kubernetes is hosted in Linux, and so Presto is part of that as well. So I work very closely with the foundation. I'm the chair of their outreach team, and I've been in the database space for over 15 years across different relational, non-relational databases, DB2 distributed, Couchbase, Kinetica on the GPU analytics side, and now Ahana in the disaggregated stack where the query engine is increasingly separate from the storage itself. All right, so that's a little bit about me. Let's jump to it. So I'll talk a little bit about Presto, obviously, a little bit of history, introduction to Presto, what makes Presto different. We'll take a look at the query, life of query at a high level. And then depending on how I do on the timer, I will maybe give you a quick peek into the running Presto in the cloud on AWS, specifically with Ahana, which is essentially a managed service for Presto. So if you look back at the database kind of engine space, and you think about federation, a federated engine essentially is a query engine that can query from different data sources. And so it can essentially do a join across data sources. It can pull data from a range of different data sources, not just the one that it is managing. Presto is a disaggregated engine. Let me actually, so it's a disaggregated engine, meaning that it's a query engine, but it actually doesn't manage the data itself. The data can be in a data lake like S3, GCS, or it can be in a range of different data sources. And these can be relational, non-relational, MySQL, Postgres, or you could have NoSQLs, Mongo, as well as JSON, search-based technologies like Elastic, streaming technologies like Kafka, and so on. We'll talk a little bit more about that. And so that's what federation is. But federation isn't a new concept. We've actually had federation for years and years. The first papers were probably written in the 80s. And over time, there were different types of engines that developed. In the 90s, data warehouse was all the rage, 90s and 2000s. But once Hadoop, once the Google file system paper came out in 2003, a lot changed in the data space. MapReduce came about, which is the next session. Hadoop came about, and at the same time, there were federated system papers like by Laura Haas, the Garlic paper by Laura Haas for DB2, and that also led to a lot of data source explosion, right? There were a lot of purpose-built data sources that the data platform team started to build and use, and that created different new problems, right? And so SQL Federation kind of came back with the Dremel paper in 2010, SQL++ and others. And today we are seeing Presto as the de facto query engine for the data lakes for federation. It's one of the best engines for federation and one of the engines for SQL analytics for data lakes. So so a little bit of view of where things emerged and came from. As everyone knows, the storage and compute are increasingly being separated out. Typically in a database, you have your parser, compiler, optimizer, query engine, the execution engine, and then storage engine. And now that is separated out because of the ubiquity of object stores. Object stores like S3 are extremely efficient and extremely affordable, which is why an entire ecosystem has emerged around them to be able to query the data that's in there. Now the challenge is that it's not structured. It's not necessarily rows and columns, and that's where this open data analytics comes in, where there's new formats like ORC and Parquet that have come about. So really what we're seeing is the space emerging with this open data lake analytics concept for two key reasons. Being able to make more decisions and get more insights from data that's in object stores. There's a ton of structured, unstructured data there, as well as because of this disaggregation of storage and compute, new technologies have emerged to for this new model. So what is Presto? Fundamentally, Presto is a distributed SQL query engine. So you're talking about a coordinator and a set of workers. The workers essentially take on work that's distributed across them, read data in and process the query. The results go back to the coordinator, and then that goes back to the client. It's ANSI SQL compatible, and so it is, which is why it is so incredibly popular. Because it uses JDBC, ODBC drivers, which are pretty standard open interfaces. And it also connects with a range of different sources, and I'll talk about that in a minute. It's designed to be interactive, meaning that Presto was actually created at Facebook to replace Hive. Now, for those of you who know the big data ecosystem, the Hive query language was built, it's more of a batch analytics engine, and Presto replaced it to be more interactive. And so many times we've seen 10 to 15x performance improvement between, from a migration from Hive to Presto, and that's kind of why Facebook created it. At Facebook, there are thousands and thousands of servers of Presto. Same with Uber, based on some of their sessions and discussions. Half the company at Uber touches Presto, the Presto cluster at least once a month, and that's how powerful the analytics are that they run on top of it. It is an open source project. It's github.com/PrestoDB, and as I mentioned, it is hosted under the Presto Foundation as a part of Linux Foundation. Completely open governance, open principles, meant to be vendor neutral, which is obviously very important from a community perspective for a project to thrive. And Ahana is part of that foundation. Now let's take a look at the architecture. So Presto is a distributed engine. You have a coordinator. The coordinator is responsible for the scheduling of the query itself. So the analyzing the query, looking at the plan, scheduling it across n workers that the cluster may have, and then each worker can then look at the part of the data that it's been assigned. Typically, data in the data lakes is partitioned. There are many different many different schemes for structuring your data, partitioning, bucketing, etc. And each worker gets a split that's assigned to it that it can then operate on, processes that data, aggregates it, and gives it back to the coordinator. Now, as I was mentioning, Presto is also a federated engine, and this means that it can connect to a range of different data sources. We see data lakes being used the most, and that's S3 and GCS and Azure Blob Store. But it also has connectors to MySQL, Postgres, Kafka, everything here, increasing as well as some of the newer engines, newer streaming engines or real-time engines like Druid and Pinot. And the different workloads that we see are either you would kind of query the data lake itself, or you would do a join across. Typically 5 to 10% of the workload is a join across the data lake as well as the data sources like MySQL or Redshift or some other source where data might be living. And so the key is that data is never ingested into the system. Typically for cloud data warehouses, you first have to ingest data into those systems, get stored in some proprietary format, which might be optimized, and then you run the query. But in case of Presto, all of it is in place. So it reduces the need for ETL, it reduces the need for movement of data or trading copies of data, which gets expensive as well. And that's why it is starting to become extremely popular for these interactive workloads, data discovery kind of use cases for both data analytics, which is for structured data, as well as for data science with SQL notebooks where you are trying to look for patterns and you may not know exactly what to look for or query or predicate to use. And so because it's so interactive on a massive amount of data, it still gives you a very good performance from query latency perspective. So, you should be asking, okay, is Presto a database? Partly, it does not manage your data. It's mostly the query engine that sits on top, and then it queries and processes that data in place. Now, with technologies and managed services like Ahana, you do get a caching layer that's built in so that you're not reading that data over and over again from the underlying system, and that helps with performance improvements. Is it related with Hadoop? Is the common question that comes up. Now, Presto emerged from the Hadoop ecosystem in some ways. So a lot of the characteristics like config.properties, JVM properties, node properties, a lot of these complexities actually kind of come from the Hadoop ecosystem. In addition to that, Presto itself doesn't have a system catalog. And so when I say system catalog, typically when you query MySQL, you can you say show catalogs or show tables. It'll give you a list of all the tables for a database or for a schema. In this case, in the case of Presto, as well as some of the other engines, Presto depends on a system catalog, an operational catalog. And so there are two different catalogs that it connects with. It connects with a Hive Metastore catalog. And so the Hive Metastore catalog, it's not the Hive language, but it's actually just the catalog to store information about tables, databases, tables, and columns, as well as the AWS catalog AWS Glue, which is available on AWS. And these catalogs essentially map the objects in the data lake to databases, tables, and rows. Now, how is this different from a data warehouse is one of the other questions that we get. And the way it's different is as I mentioned earlier, it queries data in place. So there is no need for ingestion. There is no need to copy additional data to yet another place. It essentially queries that information in place. All right, so let's say you use Presto. What does that ecosystem look like, right? What does the stack look like typically? And this is actually a deployment that Twitter uses. So Twitter is a heavy user of Presto. They present. I just recently co-presented at another event with Twitter, and they have a range of different backend sources. So underneath, they have HDFS as well as S3 and GCS. They use the Hive Metastore as a catalog, as I was just mentioning, and then they use the best query engine for the job that they're trying to run for the workload that matches. For interactive, for data science, increasingly they're using Presto. Hive has slowly been transitioned over. Spark SQL is typically used for batch analytics jobs, for data engineering jobs. And then on the top, they have a range of different BI tools, anything that connects with JDBC, as well as notebooks. And for data science, they use Zeppelin, which then connects into JDBC to Presto. So what makes Presto different from some of the other query engines? So what we see is Presto is an extremely scalable architecture, a lot of plugins and connectors, as I mentioned. Not only do you have connectors to the databases and data stores, but also you have plugins to a range of different parts of the ecosystem. For example, Ahana just built a Ranger plugin for Presto, an open source that to be able to integrate authorization, fine-grained access control with Presto. And it has a very, very pluggable architecture that allows anybody, Java developers, to build and integrate into it. And that's why it's quite popular because of this API that exists. And the third one is performance. Presto is an in-memory system. It is completely pipelined. And so because of this, it performs really well compared to the previous generation of query engines that were not in memory, as well as that used different architecture and not a pipelining architecture. And so these are the kind of things that make it different. Now, I talked a little bit about the coordinator and the worker. So this is typically how it would work. clusters, Presto clusters scale up to 1,000 nodes. Facebook is actually working on a multiple coordinator approach where you can have a 1 to n coordinators. This is coming out pretty soon, being open source pretty soon. And this will allow the clusters to be scaled even beyond 1,000 workers to grow to a much larger capacity. So under the hood, this is kind of what the architecture looks like. So you have the clients on the top. Typically, these are it could be BI tools, Tableau, Looker, Superset, all connecting via JDBC or ODBC to the Presto coordinator. The SQL is either generated or written. Data scientists may have written their own SQL. Not all of it is optimized, and so sometimes you see bad queries that are written as well. And so those queries go down to the parser analyzer, which is essentially the optimizer. The optimizer comes up with a plan, right? And so the planner here is the optimizer. It then pushes it out to the scheduler based on cost estimates, based on cardinality. It comes up with what it thinks is the best plan. There are a couple of different approaches to planning underneath Presto. So there's a rules-based optimizer, which basically goes through certain rules to see what does the query satisfy and uses those to come up with a plan. And then there's a cost-based optimizer. A cost-based optimizer typically, like other databases, depends on statistics. And so if you have statistics, then you can use costing and figure out what the join ordering should be, and should it be switched over for a smaller table and a larger table, and what that ordering should be, and so the optimizer takes care of these aspects, and then the workers go ahead and pull data in parallel with the from the underlying systems to run that plan, execute that plan, and then send back the results back to the coordinator. The metadata API connects to the Hive Metastore or the AWS Glue catalog, as I mentioned earlier, to get information about where this data lives, which worker has, which table is externally located in which bucket, for example, and what is the path to that bucket. Now, there's a range of different connectors. We see that we see the most popular ones tend to be the data lakes. Beyond that, we see MySQL, Postgres, as well as Kafka streaming comes up in more and more, as well as JSON. So JSON based, so Elastic tends to come up as well. And so you can perform a query and a join across multiple data sources with Presto. All right, let's see how I'm doing on time here. So I've talked about some of these concepts. So you have the concept of a connector, the concept of a catalog, schemas, which we essentially organize tables, and then the tables themselves. And so let's see here. Obviously, when you're touching data, authorization, authentication, security become an important aspect. Presto connects with a range of different options. For authentication, it can connect with LDAP, as well as it has. We've added password-based, kind of file-based authentication. For authorization, there are different concepts. There's file-based authorization as well as integrations like the Ranger plugin, which give you much more finer authorization on individual table level or an individual column level, and so on. Now, one of the strengths of Presto is open formats, that it runs on a range of open formats. The ORC and Parquet tend to be the most efficient and the most performant ones. But we see that from data engineering jobs, you might end up with a range of different formats. And many times what we see is we use a create table as select from kind of statements, where you essentially take that data and store it in another format. And we see query performance improving dramatically when using ORC or Parquet, because there are specific optimizations in the Presto engine to actually improve the scan performance, the repartitioning performance, etc. For example, for ORC. We've also added CSV support now to Presto, and that's available as well. So I've covered some of this. Life of a query. Let's take a look at this next. So typically, if it's select, you would expect, a standard plan that comes out of it. Presto is no different. This is a very simple plan. You scan for the orders table, and you get your output back into your client, where you see the results of the query. All right, let me just put one last slide, and then we'll wrap up here. And so Presto can be pretty complicated. With Ahana, you can run Presto in the cloud. So it's essentially a managed service on AWS that's fully containerized, running on Kubernetes on EKS. And this allows you to get the best of Presto with the power of Presto, the federation, the data lake analytics, all with kind of a container-centric as well as a cloud-native format. So with that, back to you, Doug. I think I'm wrapping up.
Awesome. Thank you very much. Everybody give Dipti real and virtual claps. Thank you very much. That's great stuff. Thank you. As much as